Okay, so the very last thing we have to talk about with this section, operations of complex numbers, is multiplying or dividing complex numbers, dividing or with fractions of complex numbers. So here's the issue that we're going to run into and the reason why we need to solve these types of problems, okay? So if you remember, expressions in simplest form cannot have square roots in the denominator. Way back a couple weeks ago, when we were first talking about simplifying radicals, we wrote that there are 3 rules when it came to simplifying radicals. Rule number 1 was you cannot have something, you can't have the radicand divisible by any perfect square. So, for instance, the square root of 24 would not be simplified because 24 is divisible by a perfect square, right? Divisible by 4 specifically. That was rule number 1. Rule number 2 said we couldn't have any fractions inside my radical. So I couldn't have something like the square root of 3/4. You know, that would not be simplified. But the very last rule, the third one, said that we could not have the square roots in the denominator. Okay? So that's the issue that we're going to run into again here, and this is the reason we need to solve it. If you remember imaginary numbers, the imaginary number I is equal to the square root of -1. So if I have a fraction with I in the denominator, well then I technically have a fraction with the square root in the denominator. And that's something I can't have. We need to take care of it, simplify it so that there is no square root, or essentially there is no I in the denominator. So to do this, this is our rule right here, it's in bold. We're going to multiply the numerator and denominator by the complex conjugate of the denominator. So, if you remember back when we first dealt with this rule, having a radical in the denominator, we had a problem something like, I don't remember specifically what it was, but it was something like 4 over the square root of 5. And the problem is we have a square root in the denominator. At that time, what we did to simplify it was we multiplied it by 1. But a version of 1 that would create a perfect square in the denominator. So, we multiplied this equation by the square root of 5 over the square root of 5. This is equivalent to 1, right? Same thing on top as it is on bottom. So I'm not changing the value of the fraction 4 over the square root of 5. But when I multiply them together, I would have a perfect square in the denominator. Thus, when I simplified it, it would not be a radical anymore. So we're going to approach these problems in a very similar way. But this is what we're going to multiply by. We're going to multiply the numerator and denominator by the complex conjugate of the denominator. Alright, so let's take a look at some of these problems. Our first one, 3 plus 10i over 5i. So again, the issue is we have to simplify the fact that there's I in the denominator. We don't want I in the denominator. So what am I going to do? Well, I'm going to multiply this by, what does it say? I'm going to multiply the numerator and denominator by the complex conjugate of the denominator. So the denominator is 5i. The complex conjugate of 5i is negative 5i. So I'm going to multiply the denominator by negative 5i. I'll multiply the numerator by negative 5i. Okay? Remember, complex conjugate is just the basically changing the sign for the I term. So if you have your complex number a plus bi, we already talked about this in a previous video. A plus bi. A is a real number, bi is the imaginary part. The complex conjugate is just a minus bi. So all you're doing is changing the sign in front of the imaginary part. Okay, so imaginary number here is 5i, it's positive 5i, so the complex conjugate is negative 5i. But let's continue this problem, so multiply these out. So at the top I have 3 plus the square root, or sorry, 3 plus 10i times negative 5i. I'm going to rewrite this as negative 5i times 3 plus 10i. And I'm putting this in parentheses because this is considered one group, one numerator, right? And I'm multiplying that whole thing by negative 5i. So that's the reason for the parentheses. I will be distributing that in a moment, but let's go ahead and multiply the bottom. The bottom, 5 times negative 5 would be a negative 25, and the I and I make an I squared. Again, something we will be able to simplify a little bit more in our next step. So our next step, let's go ahead and distribute the numerator, multiply these out. Negative 5i times 3 is negative 15i. Negative 5i times 10i is negative 50i squared. And then this is all divided by negative 25i squared. But let's go ahead and simplify this as well. Remember, I squared is equivalent to negative 1. So really, this is negative 25 times negative 1. All right, negative 25 times I squared is the same thing as negative 25 times negative 1. So that's going to be a positive 25. Okay. Also, we could probably go ahead and simplify this I squared too. That I squared, again, is equivalent to negative 1. So really, this is the same as negative 50 times negative 1, which, I mean, if I go ahead and multiply them, that's just a positive 50, correct? So that's where I'm getting the positive 50 from. Remember, this was, I kind of just combined it with this step. I didn't write it all out, but this was negative 50 times I squared, which again is negative 50 times negative 1, which is a positive 50. So that's the reason you see a positive 50 there. All right, and it looks good. At this point, we would normally be done. However, there is a little more simplifying to do. I noticed that, you know, the 15 over 25 and the 50 over 25, they're both, you know, reducible fractions. So let me separate this 25 out into both of these terms. So negative 15i over 25 plus then 50 over 25. So I'm simply separating these two into their own fractions and having both of them divided by 25. Because what this says here is I'm dividing 25 into both of these. So I can do it together like I have it, or I can do it separate, which I plan on. So these fractions now, we can reduce them. That's the reason why I separated them. I can divide both of these by 5, making this negative 3/5 I. And 50 divided by 25 is going to be 2. So our final answer is that. The only thing maybe I would change is the fact that it should be written in this format with the real part first. So, I mean, if I did that, it'd be a positive 2, then minus 3/5 I, because it is a negative 3/5. So that's why I have the minus there. Okay. And this is probably a better way to write your answer. Either is correct technically, but it is sort of more standard to write it with the real part first. Alright, so let's try it now then. I'll let you kind of like look at these steps for a minute and let that sort of sink in. So this is a good summary of what we just did. Multiply the numerator and denominator by the conjugate, which was negative 5i. Obviously, they multiplied it out. You see what they got. Remember, they changed this to a positive 50. And then they simplified it. Now, they simplified it without separating it first. I separated it first and then simplified it. But you can see they went ahead and did that before breaking it up anyway. So it's all good. Either way works. I like personally separating them out and then simplifying, but to each their own. All right, so our second example, 2 plus 8i over 4 minus 2i. So again, our steps. We're going to need to multiply by the complex conjugate. Remember, that just outlines right here. You know, multiply by the complex conjugate. So, what is the complex conjugate of the denominator? The denominator again is 4 minus 2i. The complex conjugate of that would just be changing the sign for the imaginary part. So, 4 plus 2i. Alright, so I'm going to multiply this by 4 plus 2i and the top by 4 plus 2i. Alright, so that's the complex conjugate of 4 minus 2i. Alright, let me trace that. Alright, so again, these are groups. So the numerator is really something I'm going to be foiling. Let me write it out and then I'll foil it as well. So it's 2 plus 8i times 4 plus 2i. Over the same thing in the denominator, this is something I will be foiling. I have 4 minus 2i and 4 plus 2i. So one thing at a time, let's go ahead and multiply the top together, so we'll FOIL them. So distributing, the 2 distributing, 2 times 4, and then 2 times 2i. So 2 times 4 is 8, and 2 times 2i is 4i. All right, now let's distribute the 8i. So 8i times 4 and 8i times 2i. So the 8i times 4 is a positive 32i. And 8i times 2i is going to be 16i squared. Now on the bottom, do the same thing. We'll distribute here. So the 4 times the 4 is going to be 16. The 4 times 2i is going to be 8i. And now the negative 2i, we do have to keep in mind that this is a negative 2i. Negative 2i times 4 and negative 2i times positive 2i. So negative 2i times 4 is negative 8i. Negative 2i times positive 2i is going to be a negative 4i squared. Alright, so let's look at these individually and clean it up a bit. So there's some cleaning up, some combining of like terms I need to do in the numerator and the denominator before I move on. So let me do that over here, kind of on the side. So my numerator is 8. Let me just copy it down. 8 plus 4i plus 32i plus 16i squared. Alright, so these terms I can combine. They're like terms. So let's bring the 8 down. 4 and 32 will make 36i. And then this, remember, is negative 1. So 16 times negative 1 is negative 16. So if I combine the 8 and the negative 16, I should have negative 8 plus 36i. So let's go ahead and put that back over here. My numerator is negative 8 plus 36i. Now let's go ahead and simplify the denominator. See if I can have room for that. So 16 plus 8i. Right now I'm just copying it down. Minus 8i minus 4i squared. So again, this is just some scratch work. So same as before, let's combine these like terms. 8i minus 8i. You might realize that these cancel each other out, right? So they're going to be 0i. It's not going to be any more i's there. So let's bring the 16 down. Now this, remember, I squared is equal to negative 1. So I have negative 4 times negative 1, which is a positive 4. So I have 16 plus 4 at the bottom. Right? Because the i's are gone, so it's just a 16, and it's just now a positive 4. So that equals 20. So my denominator is 20. Alright? This looks good. The only other thing now is let's break it up and let's simplify our two fractions. So the negative 8 over 20 plus the 36i over 20. Just reduce the fractions. So the first fraction, I can divide both of these by 4. So if I reduce that by 4, then the top's going to be negative 2, and the bottom's going to be 5. So we have negative 2/5. And the other fraction, 36 and 20, I can divide these both by 4 as well. So the 36 divided by 4 is going to make the top part 9i, and the 20 divided by 4 is going to be 5. Alright, so there we go. You can leave it like this. You can also, if you wanted to, put it back together because both denominators are the same. This is the same as negative 2 plus 9i over 5. Again, you can really only do that because the denominators are exactly the same. Typically, when we simplify these, that's probably not the case, and we'll just leave it, separated. But just keep in mind that that's the same answer as this. I don't know if it's going to be written on a test any differently, but just keep that in mind, I suppose. Anyway, the most important part is not necessarily that. It's just the rest of the problem, Making sure that you multiply by the complex conjugate, okay? And then multiplying the complex conjugate is what we did yesterday. Basically, when we multiply these together, it's FOILing. We FOILed this in the previous video, the previous part of this section. And, simplifying the numerator, simplifying the denominator. And just simplifying our fractions at the very end. So it is kind of a tedious task, but, it does work out. Let's see if there's anything else I want to do. I think that pretty much covers the bulk of it. These are just some more examples for practice. If you would like to try them, you certainly can. Okay, you can pause the video and try them. I'm going to go ahead and show you the answers so you can check your work. So There we go. And then this one as well. Alright. So that's going to be it, guys. That's it for this section. Expect a quiz and test coming up sometime soon. I will see you guys later.